Greetings, greetings. I hope that you are all excited. It's the last leg of the OPC Day Finland, and the best presentations are now kept for this last part so that everybody is awake. So the topic of this presentation is not so much focused on the DEXPI OPC UA companion specification. I want to talk about, in general, how we can use OPC UA as a vehicle to create an open ecosystem for this digital twin, industrial, IoT, Internet of Things, and so on. So you are all familiar with this kind of concepts. It's very now big buzzword, but what does it really mean? Of course, it means that we have a wealth of static, that means like design information, all kinds of design aspects coming from requirements to modeling, 2D modeling, 3D modeling, and so on. And also dynamic information. So we have data coming from the automation systems, as we have been hearing a lot today. We have information coming from maintenance databases. We have information coming from simulation models of the system. But you have to think about that this information, these pieces of information are important, but it's equally important the data models that they follow. That these data models are open, they are based on standards. They are not some proprietary vendor-specific data models. So if you think about design models, they should be stored in formats that are standards, not just some tool-specific formats. And this has many implications if we have this kind of standardization at this lower level. The models and the information follows standard data formats. And we can also access them using some standard communication platforms. And in this case, OPC UA is a very good candidate to do so. Then we can imagine that we have a unified access to all these different pieces of information. That gives us a lot of potential when we do handover from one design phase to the next, from requirements to process flow diagram design, piping and instrumentation design, then 3D design and automation design, and it goes on. But also handover between owner operators and subcontractors. They can select one piece of the process, and they can ask that, can you please give me an offer? What do you suggest for this part of the process? Of course, migration of old plants, integration of plants into a fleet is also an issue. Companies have some kind of ecosystem already, and then they acquire a new company that has already some other plants, and they have to find a way to integrate them in their own fleets. Consider also the future-proofing of data, future-proofing of design data. How often do we have to go back to paper copies of old designs? Because the tools that were used to draw these things have long gone. So we now have PDFs or paper copies or pictures or scanned documents of that. So what can we do if we have this data in an open format? Apart from doing this handover, we can also more easily exploit the knowledge, the tacit knowledge in these diagrams. Let's say if we want to build a new feedback loop, we can easily request to see examples of past feedback loops, and so on. And in the ecosystem level, if we have all these sources as open standard data formats and accessible using an open interface, it makes a better business proposition for small, medium enterprises, service providers, to use this information and then provide services. Okay, I'm sorry about this picture, you cannot really see that well, but the idea is that we want to have data sources based on standards. Might be from UML, SysML, and XMI, all the way to ISO 59226 for piping instrumentation diagrams, to simulation standards like this FMI and K-POPEN, control automation standards like the 61131 and the 64099 and so on. We have a standard for the communication that with companion specifications, it can model all these different aspects of the system. And we can then use this to support services. So these are just some examples. The idea is that if we can prove that this kind of ecosystem can work, then it is expected that this will grow. And there will be more and more services provided by third-party companies. We heard earlier about edge computing, and sometimes we need to have automation closer to the system because of latency and real-time requirements. So we have been experimenting with the concept of IIoT node. Now we have in our disposal devices, like there are available devices to the average engineer that are extremely powerful. So as an example, I can note this device called Latte Panda. There are similar devices by other vendors, other manufacturers. Just as an example, this thing runs normal Windows applications, but has a built-in Arduino. So it can have TTL level I/O, but at the same level it can support, at the same time it can support Wi-Fi, Bluetooth, LAN, Ethernet, and so on. And we can use this to run simulations using the same simulation tools we can use on our laptops and our computers. And we can call this our simulation IIoT node. Then we can use this device also to run machine learning applications. So there are many open source development environments for machine learning and data mining. We can then do data analysis here. And again, and that can happen over OPC UA. And again, over OPC UA, we can connect to the real automation system and use data also from there. Using the Arduino interface, we can use all kinds of IoT sensors and so on. So this is just a concept that now with very readily available tools and platforms, we can experiment and we can develop ideas. The only thing that we need to be careful is that we use standards so that we avoid to develop just ad hoc solutions. So, a few words about the DEXPI OPC UA companion specification. This is just a small piece in this big picture. So, the DEXPI group, it's data exchange for the process industry group. It is a group of big owner operators and computer-aided engineering software vendors, vendors that sell tools that can draw piping and instrumentation diagrams. And the goal of this group was to develop a standard for transferring piping and instrumentation diagrams to the process diagrams from one tool to the other. So from, let's say, AutoCAD P&ID to COMOS. And now the specification is ready, and some companies already have, some software vendors have already adopted this as one of their file formats. This is an overview of the DEXPI group. You can see some quite big owner operators, software vendors that are either computer-aided engineering vendors or they are service providers. and some research members that support the specification. So this is the typical example of the P&ID that we are using to benchmark the export-import functionality of the tools, but also now there are many more case studies available apart from this. So we have piping, instrumentation, and equipment. We have symbols, labels, and engineering content. And then more information, metadata about the diagram, off-page connectors, annotation, and title blocks. These are the standards that the DEXPI specification is based on. Standards about the plant structure, the equipment, the piping components, instrumentation, and the communication. And Proteus has been is the preferred storage file format for the ISO 15926 standard. These are the companies that are involved in the DEXPI group. At this time is Autodesk, Aviva, Hexagon, Siemens, and XVisual. VTT also has a role, but it's more of a research role. We don't develop a computer-aided engineering tool. And this is the little part in the big picture that this companion specification is focused on. So we are focused on piping and instrumentation design information. Of course, similar companion specifications need to be developed also for 3D data and so on. These are the one typical use case when we have this piping instrumentation diagram and we want to move on to 3D design and control automation design. We can do that, and this can happen by different, let's say in this picture, it implies that it's one entity that is moving from the company is moving the design from one phase to the other. But in reality, it might be that a different company is doing the 3D design, a different company is doing the control automation software, a subcontractor. So it makes sense to have this kind of interface, and it might be that they start already doing something while this is not finalized. So having this real-time access to the data is quite important. So the work has started last year. Last spring, we had already 11 working group meetings. The engineering work of the specification, the generation of the node set, the generation of the vendor prototype tool is done, is completed. And the specification document is almost complete. We need to refine some aspects of it, but more or less, we are in the last steps before we have a complete draft that we can send to the TAC committee for feedback and then for voting. These are the members of the DEXPI OPC UA working group. You will see people from the OPC Foundation and also members of the DEXPI group. It's an international group. There are people from the US and also people from Europe. And this is an example of how a model, a P&ID model, looks like using the UA expert tool. So it is served over OPC UA, and we can navigate the plant model and the different equipment and different components of the equipment and so on. So what was some first learnings is that we identified a little issue about the OPC UA address space model, that it doesn't support multiple inheritance, although the DEXPI model did use that feature. So one class could inherit from many classes there. So we had to do something, so we added one more information source apart from the DEXPI specification that gave us the hierarchy using single inheritance. Then we have identified some redundancy in the companion specification document. So the document itself has these long lists of objects and object types, basically repeating the node set file that is also deliverable. So if we have this information in the node set file, I don't know how important it is to repeat that also in the PDF document, and it doesn't look very nice. So, but that's not a big deal. And mapping of the engineering units is problematic. So the DEXPI group is using engineering units from this post-Caesar reference data. So we have to have one mapping between these post-Caesar units and the United Nations units that are used by OPC UA. So that's one extra information source that we need to have. And sometimes we have to define transformations, because we don't have the exact unit, but we have something that if we multiply, divide, or do some transformation, we can have it. And then we have a different mapping between the United Nations units and how they should be in OPC UA. So a third information source that comes into the picture. So, but anyway, these things are not very big issues, and the engineering units part is already under consideration for the OPC, from the OPC Foundation. So, in general, this is a very, very interesting research direction for us, this kind of open ecosystem describing both design and operational and maintenance information, have a holistic approach of the plant based on standards for data and standards for communication in order to be able to support services that are vendor agnostic, they are interoperable. It's a very, very important research goal for us at VTT. And we are now preparing both EU and Business Finland projects. So if you think that you have some research interests related to that, you are welcome to contact me, and we are always looking for partners in these projects.